Hello YouTube, RJ. Hey, quick little video today. I wanted to show you a piece of equipment, very old piece of equipment I own, quite vintage. It's not electronics based, but I think you'll find it interesting anyway. But many people probably have never seen one of these. So if you have, fantastic. If you haven't, hopefully this will illuminate you a little bit. What I have here is a very, very old piece of equipment. You can see how the instructions look, how they're just, they're like ate away at the edges and stuff. But this is a from resident read tachometer, or many people call them Vibraplex tachometers because Vibraplex was the big company I think that started them. And let me get this out where you can see it. We'll move the box. And this is my Vibraplex tachometer, and it's a very simple device. It works on a very simple principle, and it was kind of the standard for many years of how you set RPMs or measured RPMs on things. These could be, they have places on the back. Let me turn it around. They have places on the back for screwing to mounts. You could mount these permanently to a piece of equipment to monitor the RPM, or you could use them as a handheld instrument. And so what they are, all of these little squares that you see, some of them vibrating a little bit along here, are reeds. They're just little reeds, basically like the reed inside of a relay that you see with the contacts on it. And they've got little painted spots on them to make them stand out. And each one of them are different lengths. And the length of them are set to resonate at certain frequencies. And so instead of being electronic where we actually count the rotation of something to get the RPMs, the revolutions per minute, this works off the principle that when something turns, nothing is ever perfectly balanced. So there's going to be some imbalances in anything, and as it turns, that will generate vibrations. They may be very mild, but they'll be there. And what will happen is you'll have a predominant vibration of the frequency of the rotation of the device. So whatever the heaviest spot of the rotating piece will pull that way more than anything else. And as it swings around, it creates a vibration at the RPM of the device. So what will happen is the reeds on here will vibrate, but one in the right frequency, the same frequency as the rotation of the object, will be predominant compared to the rest. And you can get down to a little more precise. This doesn't read very precise, as you can see. It's not very granular in RPM. This is 1,000 it's times 100 RPM, so it's 1,000 here, 1,500 RPMs here. So you get down to, well, there's 4 marks between each of these, and there's 5 marks between here, so it's 100 RPM each major mark. So 3 between them generates you 25 RPM. So this thing is calibrated to 25, or let's put it this way. Its markings give you out to 25. Each reed relay is 25 RPM apart. And you can get down better than that by looking at which ones are vibrating and which ones next to them are vibrating, how much they're vibrating, and you can kind of correlate in between those somewhat. So people that use these a lot could get pretty accurate with them actually. So anyway, this is it. It's an interesting old piece of technology. So I thought maybe I'd go out and find something, one of my pieces of equipment that we could set this on and see if we could read the RPMs and see how accurate it is. And I'll try to pick something I know what the RPM of it is. Let's see what I can find. We'll see if this thing works and give you an idea of what it looks like. Okay, so I thought, well, what could we test the Vibraplex tachometer on? And it occurred to me, how about my generator? So I went out behind the garage and I've put it on here, and I don't know how well it's going to work or not work, but let me set the camera up. All right, let's get the generator going and see what we get. Okay, I wanted to point out that while the camera does kind of affect what you're seeing on the video. If you look and see the 1500 at the top rail, that's 1500. Each heavy line is 100 RPM. So if you have 15 and 16, then another one for 17. The third one after 15 is 1800. If you notice, you'll see that it's swinging wider up and down, but you're not seeing what we are actually seeing. The camera's affecting it. It is definitely going from literally the bottom to the top of the opening, back and forth very rapidly. It's very clear that that is the RPM the engine's running at. You have different harmonics. You'll see them vibrating in different areas. Things like the cabinet it's sitting on is vibrating at different frequencies, but you can see the very predominant. Now, if this was mounted straight on the generator where it didn't have all the rattles and things from metal cases and stuff, you would see less of these harmonics. There still would be some there, but you could see the predominant. Okay, and there we have it. We have the reed tachometer. That's how it worked. It was ingenious technology, really, if you think about it. No batteries, nothing to plug in. Stick it on the valve cover of a motor or on a rotating assembly or whatever. There's screw holes in the back here. Let me show you. There's mounting holes, threaded mounting holes that you could put on brackets. You could mount to equipment, or you could build brackets to hold it on things or to just set it on things for testing. Built like a tank. This thing is cast, you know, they were built to last. There's nothing in them really to go wrong. The little reeds will last forever. They're sealed. There's no moisture that gets in them. These things will theoretically last forever. There's no need to recalibrate them. The links of the springs aren't changing, so you know they'll work forever. So anyway, thought you might find that interesting. Wanted to let you see my old reed tachometer. So hope you enjoyed it. Catch you in the next video.